Thank you. Yes, as mentioned in the introduction, or you could tell by my name, I'm from Sweden. I'm in Ericsson, and I work in the Advanced Industries team, focusing on private networks for industrial usage. And previously, I spent my days actually working with digitalization of our own manufacturing plants, so that we have the main ones in Tallinn, China, and now recently announced we are also opening up one in US. And yeah, as I said, my Finnish is limited, but I probably can say Vis G and Nelia Pisnolla. That's probably all I manage. But I want to talk a little bit about like how this journey started at Ericsson. We have been part of industrial automation projects for a long time, even before 4G, but now it's really taking off, and the industry is coming to us and asking, okay, we need to step up our digitalization journey, and what can we do about it? And as you can see, we have been part of many industrial engagements in our own plants, in other plants, together with big industrial players and with our operators, including the Elisa in the middle here, the latest one in Finland. And from these engagements, we have collected some learnings. Basically, Industry 4.0 is about customizing your products to the end customer. And if we look at the automotive industry, that's where they have come very far. So when you order your car, you click in whatever different types of configuration you want on your car, and then that ripples down into the production floor, and your unique car rolls out some days or weeks after from the production floor. And it's the same, you know, when you order something online, even with M&Ms, you can get your name on the candy today. So that's a way that they want to differentiate from the competition, and also cope with the changing and shifting customer demands. It's the same in Ericsson factories. We produced 10 radio variants back 10 years ago. Now we produce 100 per year, different variants. So this puts a lot of requirements on flexibility in our production shop floor. If our customer suddenly starts ordering one of the variants which we didn't plan or so, we need to be flexible and change that. So also the shop floor in the factory will actually be changing depending on what the customer is doing. And the truth is, most of our machines that we are connecting to make them digital, those are over cables, and it's not the optimal way to rebuild and recable everything as we change our production floors. And then there is unlicensed solutions for many of the use cases, which is fine in some cases, but there is not one stable, secure, and simple network to cope with all of this, these initiatives in the factories today. And this is really what we have tried to take this learning into our portfolio and package our networks to cope with this demand, so that Elisa and other operators can go out to the industry and say, here is the solution that fits your needs the best. Okay, so as you saw, there's common namings on the how we cope, divide the use cases. The main two buckets are the massive IoT and the critical IoT. So the massive are more the devices that you sprinkle all over the shop floor, from the NB-IoT to BLE type of use cases, where you're only gathering small amounts of data from maybe a vibration sensor. It's very stupid, maybe, the data, but it gives a lot of value. I will talk more about that in the end. And those are typically from, you know, all from the PLC data collection to, as I mentioned, the vibration sensor data. And then we come to more broadband type of use cases, where we stream real-time 3D instructions, AR content, or other types of video analytics solutions. And then when we come to the critical side, this is where we have a real high demand on the closed loop communication. So if there is a robot reading a certain value, and then you need to stop the process, which we hope we don't need to do in the factory, but that is a really critical thing if we are maybe scrapping a product because we didn't stop in time and so on. So and even on the, as we mentioned, the latency is what like determines in what bucket you end up in. And if we look at the far end here, where we talk about the later releases of 5G, this is where you can do basically deterministic networks and really cope with this, putting almost all the logic outside of the machines in the local cloud, so the edge, and then having this round trip of data and action in the factory plant. Yes, and then as we also spoke about in the other presentations, we have a way to divide the network types. So the global networks are more for covering typical city or a bigger plant. We have the local networks where you deploy a network on the premise of the site. And then, of course, it varies if you have an outdoor or indoor type of deployment. So in a mine could be both indoor and outdoor, or harsh environment could be a good example of where you need to have outdoor certified products. So if we look at the global examples, it could be like we're showing also in our booth, the ABB drive. So we're connecting and collecting data from the drive to the motor to control power consumption and collect data on how is this asset actually behaving. And local, I already mentioned, inside the plants where you want to keep data on premise, you want to ensure the latency is stable and reliable. And then the local part of the indoor will be a typical factory environment, and then outdoor could be anything from a wind farm to outdoor open pit mine. So just to explain a little bit, the different enterprises, they come with different requirements, and how you rely on. So some of them are very conservative, and they say, okay, nothing leaves my site. I don't want any dependency on the surrounding world. Okay, that would be down here in the Enterprise 5, full on-premise standalone solution. Nothing leaves the site, while some enterprises would be okay by using the public network and putting most things in the cloud. So there is a way to shift this configuration. It also gives you more or less of certain functionalities. So for example, the full on-premise, you have very high control of what is actually your performance of the network, while the top one you could have to live with that you're sharing the network with others. Okay, more about this. I think we can just quickly dive into this. So the full operator dependency would be the top one, which we talked about, enterprise number 1, where either the operator has to promise a certain network slice to the enterprise to ensure the stability and the performance, or when you have somewhat of a mix of the two, where you have maybe local processing on the site and you can have the data flowing and then you stream events out of this deployment, which is also fine in some cases. And then we have this real picky typical automotive customers where most of the data is their IP, they want to keep it on site, and this is where we have put a lot of effort on making sure that we have an off-the-shelf type of deployments that Elisa can sell directly to these demanding customers. Okay, so a little bit about the fundamentals. For cellular, it's typically a licensed spectrum. It means that if you have this licensed spectrum for a certain cause, that means only those devices will be transmitting on this spectrum, right? And this is why we see that Germany is opening up spectrum for industries, because they see this as a competitive advantage for their industry, right? And if we look at other unlicensed technologies, it will actually share the spectrum with other devices, and anyone is allowed to transmit on this, which is why in crowded fairs you typically don't have Wi-Fi or other unlicensed solutions working, and if you have a dedicated spectrum, it will still be working. And of course, this is the nightmare of the industries. If you would have people starting to host a hotspot in the factory and then suddenly you stop production lines, this is a complete nightmare. And if you're producing 2 cars per minute, you can just start counting the money on how much you're actually losing when you have these unexpected stops. There are other fundamental differences between how the access point actually handle the transition between the different cells, let's call them cells. So we see it's a very common case where you have a dedicated network for your autonomous guided vehicles, basically the moving platforms that you have seen in the Amazon warehouses, moving between cells, and when they lose connectivity, they stop working. We have seen this in our own factories too, and it's a quite common problem that they're having. But with cellular, we handle the handover between cells in another way and just makes the network as a more homogeneous network. And of course, when we are on licensed spectrum, we're allowed to transmit on a higher output power, which gives better reach. Okay. Then to sum up that it's not only the network, and basically my role in the company is also to make sure that we have partners who knows, first of all, how our network works, and that we have devices to connect and applications to collect to. And to sum up a little bit what the combination of device and network can give you in an industrial setting. I have this picture where we have the radio dot from Ericsson, which is our indoor coverage solution, and then we have on the right-hand side we have for you it's the right-hand side. We have the HMS Bolt, which is HMS is a provider of connectivity devices for machine builders, so they will be installed in anything from an ABB robot to a CNC machine. And they have launched this product to be able to upgrade existing brownfield machines, because that's also the case that many of the machines today, they have been out there for 30, 40 years, and you need to access that pool of data which you already have in there, but it's not at all connected. So that's why they have launched this product where you can simply upgrade or add some hardware to it, and then you can stream out the data from these existing machines. So to sum up the combination of network and device topic, you can have devices which are battery driven, where you use NB-IoT to maintain the life cycle. Maybe you don't have the best performance of the data streaming, but it's good enough for this one-dimensional data type use cases. You have, of course, transition between if I have a really high-end device, it might be more expensive, so you need to balance that, of course, and that comes, of course, with the performance tied to it. But what is really like common in the industrial plants is that they're asking for us to say, okay, where did I put my things? So if we, together with the device partners and our network, can enable positioning of each device, this is unlocking huge value, and it basically allows you to automate a bigger portion of your flows within the factory or outside the factory. So this is something that we're working very hard on to enable from the network. Typically today you would add an extra infrastructure to have the positioning of devices, or you need to rely on a computer vision type system. Security and latency is, of course, the devices has to have a way to ensure that there's no malicious attacks from the device to the network, and on the other hand, the other way around, that the network makes sure that there is no malicious attacks on the devices. Okay, so I have collected some of the reference cases just to show that there is a broader than just manufacturing, which is basically where I focus. So we have the FirstNet in AT&T, where all the firefighters, police, and ambulance use this dedicated network and spectrum to ensure that these, critical communication is happening. You're streaming EKG from an ambulance on a patient who is arriving to the hospital. We have power and utility plants where, basically they're doing this typical use case of knowing how is their asset behaving. But this is such a critical infrastructure for the society that they cannot allow to have, you know, a public cloud accessing this, or they're just opening up a too critical infrastructure to threats. Of course, mining is one of the places where you basically have no coverage if you're underground, and it's a strong case for having your network extended down into the mine, and it's completely shifting every day, right, too. So they're building a new tunnel, then they want to expand the network in there. They need to be able to manage the network a little bit themselves too. Oil and gas is a typical case where you also don't have the coverage from the land, and it's a very, very critical operation going on in the rigs. We have ports, and this is a classic problem that they had. They also had these movable platforms, and then when the boats came in, the Wi-Fi of the boat actually disturbed the Wi-Fi of the port, so that they would stop the operations. Yeah, and of course the reference factory in Aachen, where we have both Elisa and Ericsson is present. Elisa is one of the few operators who actually has a digital twin type solution where you can collect and visualize the data which you have in the shop floor. So that is on display over there. But let's dig into more of the discrete manufacturing use cases from our factory, since that's close to my heart. We have screwdrivers, a lot of them. We need to put screws into our products to make them stick together when we have them at our customer sites. And we have many. It's thousands of screwdrivers, and they cost a lot of money to maintain, because they have to make the right torque or our products fall apart when they end up at the customer site. So we calibrate them, and we don't really know the usage. So in China, it's easy. You can go out on the city and you can just buy sensors. So that's what they did. They just make their own vibration sensor. They strap it to the screwdriver, and then they start counting. Okay, this vibration, 1, 2, 3, 4. Okay, at 600 or 500, we need to calibrate. Then they could see, okay, this one is not calibrated at the same interval as this one, and much more timely planning of the whole operation was the result. And as you can see, 50% manual work reduction. And it's a very, let's say, stupid case, but it still brings a lot of value to the manufacturer, to just get insight into that process. And this is a classic example of a very, you know, when you push it to the limit with 5G. In this case, they produce this blade integrated disc. It's basically a propeller in the jet engine, and you make it out of one big titanium block, which is super expensive, special alloy of titanium, and they don't know until after 20 hours if this is actually good or bad result. So what they're doing instead, since this is spinning, they connect a wireless sensor, they stream the data out, they analyze the data in real time, and then as soon as something is barking the wrong direction, then they will adapt or stop the process. And then eliminating that they have spent all this time and wasting a very expensive, you know, rare material. And as you can see, it's a quite huge saving per factory if they would implement this in the whole site. And lastly, I think it's just to not go a little bit broader than manufacturing. We have connected Boliden mine for a long back. We stream data from the trucks so that the operators can sit on the surface of our earth, and they can control the machines down below in the mine. And this also saves, first of all, the safety risk of going down there, and it saves a lot of time when it comes to, if you have detonated a dynamite, you cannot go in, but if you're not in the actual car or a truck, you can go in while the dust is still settling. So this slide, I think, ended up in here by mistake, but that's fine. The main benefit that the industry is seeing is that they will have an asset, whether it's a robot, a machine, it's a screwdriver. They want to connect this one, they want to connect the data, they want to analyze it and act on the data. And this is how you end up at the business case for any industry. And this asset or what data, this will differ completely between factories even producing the same thing. I think that's how I have to sum up this slide. Thank you.
Okay, thank you, Fredrik. Any questions to Fredrik from this really interesting area? It will be interesting for every one of you in the future. Okay, if not, I always have questions. What is the coolest use case you have met so far on the Industry 4.0 area? Not maybe the most productive, but the coolest.
So okay, so it shouldn't be productive but cool. We have seen a lot of this. So I think the Blisk is one of the cool ones where you actually see, you know, there's a real value. But then there's others where we see, you know, we have this end of arm safety project together with Audi and SICK. SICK is a sensor provider, and the problem with collaborative robots, we discussed this during the lunch, is that they can still harm you if they hold something which is sharp. Even if the robot is safe, that if you touch the robot, it will stop, the tool that it's using can harm you. So what they did, they added this kit of sensors, streamed the data out over 5G, and then they're showing how we can do almost emergency stop by having the compute happening somewhere else and then feeding it back to the robot so it will stop before you get hurt. And this is the famous picture of Angela Merkel when she's trying it, and her face is like this. And you should Google it, and you will have a laugh.
Okay, thank you, Fredrik.
Thanks.
Ja sitten